Alrighty. So what we're going to do today is solve problems that can really only be done with a calculator. Up to this point, we've sort of just kept them nice and neat where they were like powers of 2 or powers of 3 or powers of 5. That's where it will change today. There's one more like log property that we need to learn, which is called the change of base property. And the good news is this property is so necessary that most of our calculators have it kind of built in. However, it's kind of a newish technology, so even if you have a calculator that might be like 5 years old, it might not have this built in. So we do have sort of a formula that you can use if your calculator doesn't have it built in. But let me kind of show you why we have to do this today. If we had a problem like this, and you could very well get a problem like this on today's quiz. So if we had a problem like this, we should be able to evaluate and solve for x without a calculator, right? Because I can't like square an 8 and make it, or square a 4 and make it an 8, but can't I rewrite both of these as a base 2? So if I rewrote this as 2 squared to the power of x, and then I rewrote this as 2 cubed, I could then use my exponent properties, and I could say that 2x equals 3, and so x is 3/2. All right, so we've sort of sheltered you to have only exposure to problems where you could kind of do things like that if it wasn't something more obvious like 4 to the what equals 16. This is where it gets a little bit harder. So 4 to the x equaling 15, x is not a whole number, right? Because it's certainly bigger than 1, but it's smaller than 2. And so maybe your first inclination is like, oh, the variable is in the exponent, so maybe I log it out in order to try to solve it. So if we wrote this as a log, this is good practice for today's quiz, this would be log base what? Log base 4 of 15 equals x. And even then, you can't solve it. So what you're going to learn today is how to punch that into your calculator. All right? That's with this new change of base formula. These are the 2 buttons you're going to use the most. So you might want to just look at your calculator, make sure you can find those. They are different. LOG is log base 10, and LN is log base E. All right, we don't write the little e, but anytime you have a problem with like natural log e to the 5th, there's really a tiny little e right here. Right, we just don't write it. Okay. So you might see problems that just are like this. And I mean, this is literally just punching buttons on your calculator and getting an answer. So, do you anticipate any troubles punching these in? Do we need to practice any of these together? I'm thinking no. But why don't you try this number 4?
It's not possible.
Hopefully you have an intuition that it's not possible. So what does the calculator tell you?
No real answers.
It says no real answers. Because this isn't possible, right? There's no exponent that turns a 10 into a -7. You should never have negative numbers in either of these positions of a log. So do be aware that you could get an error on your calculator. You know, we could throw at you a problem that really the answer is that it's no solution. If you don't catch it early enough and you go and you're punching buttons on your calculator and you get an error, it might be that problem is just not solvable. Okay, so just be aware of that. So then your problems might evolve to look a little bit more like this. So you're going to be asked to solve for x. And if I look at this particular problem, this piece right here is some decimal that I can get from my calculator. So grab your calculator, type that in, and tell me what you get.
1.255.
1.255?
Yeah.
Okay, so that's what that is. Log 18 is 1.255 minus 2x equals 5. Would you know how to solve for x in this particular problem now?
Yes.
Sure, right? You subtract this over to here, divide by a -2. Okay, so that's part of what you're going to see. Fairly straightforward. So then this one is maybe a little bit different because I can't just type in log x, right? If I type in log x, the calculator is going to spit back to me log x because it doesn't know what x is. So this one's different. The x is sort of in the log, and if your variable is in the log, what we need to do is rewrite it. And so again, this is maybe good practice for today's quiz. If I was going to rewrite this, what would be the base? It's a base 10 number. What's the exponent? A 7.5, and then it equals x. And now you know what x is. And you could leave it like that or type it into your calculator and write out the really big, long number. Okay? So let's try another couple more like that. So if the thing you need to watch out for is if your variable x is inside of a log or inside the exponent. If that's the case, you almost always have to rewrite it in its other form and then reach for your calculator and evaluate it. So for this particular problem, this is a base e. My x is stuck inside the log, so I'm going to rewrite it as e to the 3.8 equals x plus 2. And at this point, you can reach for your calculator, figure out what decimal that is. So tell me, what do we get when we do e to the 3.8?
44.7.
44.7? Does that sound about right? Okay. 44.7 is equal to x plus 2. Yeah, subtract. All right, so x is 42.7. So in some ways, I think you'll find these problems very intuitive and pretty straightforward. This one, the x is in the exponent, so I do have to write this one as a log. This would be log base 10, so that would be log of something equals something. The 2x goes here, the 0.57 goes here, and then we can reach for our calculators to figure out what this is. What do we get for that? Luckily, that's base 10, so we use just the LOG button.
-0.244.
Yep, okay. It's -0.244. Yep, that sounds about right to me.
How does it become negative?
Why would it be a negative?
Like, how is it negative?
So let's think about what the question is. The question is, what exponent turns a 10 into like a 1/2-ish?
Because
So not only does it have to make the 10 a smaller number, but it also kind of has to flip it. So that's part of why that's happening. And then you just divide by 2. And so what? -0.122 is equal to x. All right. For this last one, let's see. We would rewrite this as a log. Again, good practice for today. What kind of log would it be? Natural log. And there will be something in the natural log, and then it will equal something. What goes in the log? 12.5. And then the 3 minus x goes over here. You would then reach for your calculator and use your calculator to figure it out. Okay. So far, so good?
Yeah.
Cool. Now, what we have to do then is we have to deal with what about the situation where when you go to rewrite this, like this I can't evaluate in my head. It's not a whole number. I could guesstimate it. Right? Like, let's say this was a multiple choice question on the ACT and you didn't have a calculator. You could probably make an educated guess. Yeah, it's going to be bigger than 2, right? Because 2 squared is 4. And it's going to be smaller than a 3 because 2 to the 3rd is 8. Are you looking for these?
Yeah.
Uh-oh, some of my students have them.
Well, then I'll just do that.
You want to take these and I'll bring back, we're almost done and I'll be able to bring them back.
Okay, that's cool.
Okay.
Thanks.
Sorry. I was like, look at what I got. I got calculators. All right, so you could probably guesstimate that this is close to a 3. All right, but if we need the exact answer and we tried to use logs, this would rewrite as log base 2 of 7 equals x. Now, if I say look at your calculator and I said, where's your log base 2 button? There isn't one. Right, so that's where we have to kind of learn a little bit more of how to use the 2 buttons that are there. We can't possibly have a log base, we can't have a log button for every single possible base number. So there's 2 kind of famous ones, right, base 10 and base e. And what we'll learn is that we can change this into base 10 or base e, either one, and we do that with the change of base formula. So it looks complicated, but it's really not. All right, so if you have a log and you've got an argument that's one number and a base that's another number, and you need to figure that out, you're going to create a ratio. You're going to give the A its own log and put it on the top of the ratio. And you're going to give the B its own log and put it on the bottom of the ratio. Now, because it's a ratio, here's the interesting thing. It doesn't matter whether you choose natural log or whether you choose log base 10. It literally gives you the exact same answer because the ratio between the log A and the log B is the same. So let's try that with our calculators. It doesn't really matter whether we use natural log or base 10, so I'll just start with natural log. So if I take this, I would do natural log 5 divided by natural log 1/2. I always remember the way that I remember the formula is the base number goes on the bottom. They both start with B. Base goes on the bottom. What do we get for that? Negative 2.32? Yeah. Awesome. All right, now try it the other way. So now try it with log 5 divided by log 1/2, and you should get the same thing. Okay. So this is the formula that you kind of need to remember. But those of you who have a new-ish calculator, they have updated the operating system to allow you to type something like this in one step. So here's what I want you to look for. We are going to use what is called log base. It's all in caps in your calculator. And it is under the math button. Now, the math button, you kind of have to scroll through it. I'll give you a hint. Scroll up and look for option A. It's pretty awesome. It goes like this, and it gives you like a little box that you can fill in and a little box that you can fill in.
That's nice.
Yeah. And that's literally changed in like the last 5 years. Like when I started teaching at Creek, none of the calculators did this. So that's great. If you have the calculator, you can use this, and you might not ever need to use that. However, we do have ways of asking questions that will require you to understand this. Usually they come as like true-false questions. So then you do kind of have to understand, okay, was that property applied correctly? So these would require a change of base sort of situation. Like if I look at number 2, if I was to write that as a log, it would be log base 6 of 25 equals x minus 5. And then you would just reach for your calculator and do that in your calculator. Once and you can either do that with the change of base formula or with the whole log base built-in functionality. Either way works, okay? Do you want to do more of these together?
One more.
Oh yeah, let me talk about these. So if this was something that I had to rewrite as a log, it's actually not ready to be rewritten as a log. If you haven't tackled 9J yet, there's a few problems like this where they have these coefficients and you kind of have to know what to do with those. You need to divide it out before you rewrite it. So then you've got e to the 4x equals 8. Now you have your three pieces. We've got this piece, and this piece, and we can rewrite it as a log. But anytime you have a coefficient on your base number, you do want to divide that over, even if it's like a -1 or something. So then this would be natural log of 8 equals 4x. And then you would reach for your calculator and, you know, figure out what that is, and then divide by 4. So this one's really similar. There's one subtle difference that makes a big difference. So let's say you divide both sides by -2. Excuse me. You get e to the 4x equals -8. That's not possible. Now, hopefully you would catch it right here. And you'd say, oh, I can tell that there's no way I could take a 2.7, multiply it by itself over and over and over, and somehow get a negative result. Now, if you don't catch it, and you go ahead and rewrite this as a log and reach for your calculator should give you an error. So at that point, you kind of need to reconcile with yourself and go, okay, is it, you know, is this okay? And it is. Sometimes there will be problems that aren't possible. All right, so a couple quick true-false questions, and then we'll be done. Here is a problem that would require change of base. Has the change of base formula been applied correctly? No. These are very subtle things you have to look for.
No.
This is false. Because what's missing is you would need to have like a natural log 3 and a natural log 2. Okay, then it would be true. Okay, it's not just the numbers getting divided by each other. It's the numbers getting their own logs. So then what about this? Is that true or false?
True.
This is true. This is one of the properties that you need to know for tomorrow. Now, this is very often confused with the change of base because log of 3 divided by 2 is not the same as log 3 divided by log 2. So this property is often it's very often confused with the change of base because they're similar enough. So just be aware of that. As you're studying those properties for tomorrow, don't let this change of base throw things off for you. Okay? Here's what, there could be another question like this that comes up. And I think this would be fair game for tomorrow's quiz. If I gave it to you like this. That would be false. Okay, but now in your head, you know that this is a possible thing, but it's not a possible thing linked with subtracted logs. Okay, it's not a condensing property. So be careful. So this right here is false. Subtle differences. Another thing that we could throw at you that sometimes will would be something like this.
Oh. No.
You know, where it's like those two properties get confused. That's also false. Okay. All right.